So we'll look at a few examples of how we can put our formula in action. And here we need to calculate the moment that it is described below, and more importantly, the direction of that moment. The direction of the moment is very important, because if you think if you're balancing something on a pivot, it will either go down, tip up, or go down, okay? So the words that we'll be using are a clockwise or an anti-clockwise direction. Now we'll just take this example. We have our moment formula is the m equals force multiplied by the perpendicular distance, and that is the distance from the pivot. And we'll just take a wee note of what we have been given in the question. So we know that the force is equal to 300. Our distance is 1.6 meters, and we're trying to find the moment. So using our formula, we know that moment equals force times distance. Just remind ourselves of the triangle. That's the one that we're trying to find. So they've asked us to find the moment. You put your finger over the thing that you want to find, and we know then that it's force times distance. So m equals 300 multiplied by 1.6, and just slotting that into our calculator, we get 480. And don't forget our units. Well, we had newtons in our question, and it was in meters our distance was given, so it's nm. So the answer there is 480 newtons meters. Just moving down, the next bit is a practical, and I'll put up a wee video of a particular practical that we've done, but we'll just go through the theory of it. So this is just basically, we need to plan and carry out an experiment to verify the principle of moments using a suspended meter rule and attach the weights, okay? So using the principle of moments, we know that when an object is in equilibrium, okay? So in other words, it's balanced. Equal forces are acting on it. So it has balanced forces. The sum of the anti-clockwise moment about any pivot is always equal to the sum of the clockwise moment. In other words, for something to be balanced, you have to have your anti-clockwise moment is equal to your clockwise moment. And this is about the point called the pivot. And when we find that, that is called the principle of moments, if we can prove that.